Hey everyone, and welcome back to my channel. My name is Malkir. So, if you are working with containers, you are working with the Docker files. But are you sure your Docker file are secure? A single insecure Docker file can expose your entire application to risk, from leaking secrets to giving attackers root access. So today we are going to fix that, and we are covering the essential Dockerfile security best practice. And we will take a common insecure Dockerfile and step by step transform it from a major liability into a secure, lean, and production ready image. So let's get started. So why does this matter so much? On your left, you see the risks. So insecure image can lead to root vulnerabilities, which are critical. You can accidentally leak API keys or database credentials, and they are often bloated and slow, so which clogs your CI/CD pipelines. On the right, the reward secure images are small, which means they are faster to pull and scan, they are safe, running with the minimal privileges, and they are lean. So containing only the application code needed to run, which makes them easy to audit and deploy. So in our demo, the before, so this is our starting point. So I call this dockerfile.bad, and you will see this everywhere. So it uses the Python latest tag, and it copies everything from the current root directory right into the image, and it runs pip install, and then it runs the app. Do you see the problem? It run as a root. It's built on a full operating system, so it copies all our source code, our .git folder, everything. And as we will see, it's a huge. Let's go through the fixes. So the best practice is use a minimal base images. So first, your base images, stop using latest and stop using full OS images like Python 3.10 or Ubuntu. So these are complete operating systems packed with the tools like a curl, wget, and bash. So all things an attacker can use against you. So the solution is to use minimal image. A slim image is good, and Alpine is even better as it's a tiny security focused base, but the best for security is distroless. So distroless images contain only your application and its dependencies. No shell, no package manager, nothing for an attacker to use. Don't run as a root. So this is the most important rule. By default, container run as a root user. So if an attacker finds an exploit in your application, they can escape the container and potentially gain root access on your host machine. This is critical. So the fix is simple and mandatory. Create a dedicated unprivileged user. You used to run to add a new group and user, and then at the very end your of your Docker file, you use the user instruction to switch to that user. So this single line dramatically reduce your risk. And use multi-stage builds. What does it mean? So this is a key to getting those tiny secure images. A multi-stage build separates your build environment from your runtime environment. So look at the concept in stage 1 here. So which we call builder. So we will use a full Python image. We install our compiler. We run pip install. We build our application. And in the stage 2, We start from a clean, empty, distroless image, and we only use the copy and dash dash from equal to builder command to copy the result of our build. So this means the final image has none of your source code, no pip, no compiler, no build tools, just the final optimized application. So this is a game changer. Minimize attack surface. So every file you add to your image is a liability. You need to be explicit. So first, create a Docker ignore file. Add your .git folder, your underscore underscore py cache, underscore underscore directories, your local secrets, your readme files. So these do not belong in the image. Second, instead of copy, be explicit. Copy requirement.txt first, then run pip install, then copy. This makes your Docker layer cache far more effective. So how to handle the secrets? So this is a fatal mistake. Never write copy secret dot environment or env api underscore key equal to blah your secret. So directly in your Docker file. So these values are baked into the image layer. So anyone with the access to your image can run Docker history and read your secrets in plain text. So the solution for build time secrets, use build kit mounts. For runtime secrets, which is most common, pass them using environment variables with the E flag, or even better, use built-in secret management from Docker Swarm or Kubernetes or your cloud provider. Scan your images. So finally, you are not done until you scan you wouldn't ship code without running tests. So don't ship an image without a vulnerability scan. It's a built right into Docker. Docker scan my app latest. So you see here, or you can use fantastic open source tools like Trivi or Trivi. How do you pronounce? So just run Trivi image my app latest, and it will give you the full report of all known vulnerabilities in your base image and packages. So this allow you to fix them before they ever get to the production. So after a good Docker file, and this is a result. So this Docker file is .good. Look at the differences. It uses a multi-stage build, and starting with the Python 3.11 Slim as a builder. So it creates a non-root user. The final stage is a tiny distroless image. It copies only the installed packages from the builder. It runs as the app user. So the result, the image that's a 90 MB instead of 900 MB and has a zero critical vulnerabilities. So now let's put it all together. I'm going to jump into my terminal and show you how to do this step by step. So to practical demonstrate before versus after and show the real world impact on the size and the security. So I have created a folder, a Docker underscore security, and inside I have 5 files. So I can show you. So I have an app. This is just a simple Flask app saying hello world, exposing on port 5000. And then I have the another file that is a requirement, the Flask version 3.0.0. And then I have the Docker file. Sorry. Dockerfile, a bad example. So this one you can see Python 3.11 bookworm, that is a large full OS image, and it's, nothing else has been added, just a very simple one. But and then I have the example of the Docker good file. So well, you can see here, this is a Docker using a slim image building, that is a Python 3.11, Then it is using a virtual environment, and install all the dependencies, and then the final image, it will be using it will be using this Python 3.11 Alpine. So, and then adding a group and a user, adding the user to the new group, and then copying the virtual environment on the application, and then yeah, just uh, switching to the user, the app user, and then running the Flask. So, well, yeah, let's get started with the building. So I'm going to use Docker build dash t insecure app. So Dockerfile bad dash t. I might, okay. So yeah, so build has been completed because I already have created the image. Let's do the Docker images, and you can see insecure app, and it is taking 1.3 gig. Wow, so this is huge. And let's try to scan this file, this image with the trivy. So trivy image, and I can give this application name and with the latest tag. So let's scan this one. And well, look at this, dozens, if not hundreds of vulnerabilities, including critical ones. Well, so this is because we are using a full unpatched OS as our base. So let's do one thing. Let's run this image. Docker run insecure app, and type who am I. Wow, see. So I have a full root access inside this container, and this is extremely dangerous. So just type exit, and now let's build a secure version using our dockerfile.good, which has a multi-stage build and non-root user. So I'm just going to do docker build dash t secure app dash f and dockerfile good. Oops, missing the dot. Yeah, so it is done. And let's do compare a Docker image and grab using the app and dash e repository. Oops, missing s. Yeah, well, look at this. So insecure app is taking 1.3 gigabyte, and secure app is not even 90, it's 82.9 MB. That is a 90% reduction in size, and this is the power of multi-stage build. So, and let's try we image and secure app. Give the tag, and well, see, so you have like very minor vulnerability, and like from 100 of critical issues down to 0. So this is a massive win. And finally, let's try to get a shell. This image is distroless, so it doesn't even have a shell like bin bash. So let's just try Docker run. So see, the command fails. There is no shell, so this is a good thing, and attacker can't get shell either. So let's check the user by running the who am I command directly. So what I'm going to do is just uh, give entry point who am I and secure app. See, app user. Perfect. So we have successfully privileged our container, and finally the real test, does it still run? So I'll just do Docker run and expose the port to 5000, and I'm giving my secure app and secure app. Oh, okay, iris work, and let's just do a curl to the local host on port 5000. Yep, see, hello, this is a secure container. So yeah, it works, and this is a secure container. Don't forget to clean up. So I will just Docker stop my secure app and Docker remove my secure app. So what did we learn? So by applying this best practice, we took our image from 900 MB down to 90 MB and 100 of vulnerabilities down to 0. Remember the keys. So use a multi-stage build, run as a non-root user, use minimal base image like a distroless, and always scan your image. So that's all for today. If you found this useful, please hit that like and subscribe button, and all the code for this demo is linked in the descriptions below. So leave your questions in comments and stay secure, and I'll see you in the next one. Thank you.